Is there anyone in the orange t-shirt to start the session, or should I just? Okay.
Everything's good to go, you're live.
Well, I'm just waiting for
Yep.
the doors being closed. And okay, thank you. Hello. Hello. I'm Choroba from Prague. I work for Good Data, and I'm going to show you and share with you our story that involves JSON and various type conversions and problems with them. At the end of the talk, I'll show a link to the slides where you'll be able to click on various parts of this slide, for example, to know more about me or the firm that employs me. Okay, so let's start with a story. So we used Red Hat Enterprise Linux 6 for years, and we needed to migrate to the version 7 because 6 was going out of support. And this change meant, among other things, changes in versions of Perl and the JSON access library we used for encoding and decoding JSONs. As you can see from this, we used system Perl and vendor provided libraries. I'll get to it later. Okay, so the changes in Perl related to JSONs are related to some of the internal flags that Perl uses to know whether a scalar variable has already been used as a string or a number or whatever else. So there were some changes in this. And the library JSON access among between the versions 2.27 and 3.01, it changed some of its type conversion heuristics, which means these two changes together caused a lot of grief on our side. So the impact of the changes was that some numbers started to appear in double quotes, while some others that had appeared in double quotes before were no longer quoted, which from Perl's point of view doesn't matter much. Perl doesn't care, but our customers use various languages, quite often Java or some other typed languages, and in these languages it could be a problem. Moreover, it caused it broke a round trip. So if a customer posted a JSON to our API and they tried to get it back, the structure they get back was different. Some of the numbers were quoted differently. So this was a no-go for us. The upgrade was blocked for rather a long time, and we had to find a solution. So I'll just show you how complex the problem was by showing some examples of the changes. So one of the things that changed is handling of magic variables. It changes with the Perl version. So you can see that in the first line in the table is 5.10.1, and it shows like the code is shown in the gray background. And you can see that both the numbers are quoted in 5.10.1, but in 5.16.3, the first one is not quoted. And the same is true for JSON PP and cPanel JSON XS that I use here just as a reference. What's important here is that this change happened to our code, so that was bad. Another example that shows the inverse problem, no quotes. Again, we use UTF-8 decode on a number and then encode that number to a JSON. And suddenly, when you upgrade Perl from 5.10.1 to 5.16.3, the number is suddenly quoted as it is when you use JSON PP or cPanel JSON XS. Okay, we wanted to switch to something else. JSON XS has problems, and we thought that cPanel JSON XS would be a good replacement, but you can see that it's not. It cannot be a one-to-one replacement out of the box because it behaves differently for just another kind of trick. If you have a string that contains a number plus something that's not a number, you force it to a numeric context and then encode it to JSON. And suddenly cPanel JSON XS makes it a float, while all the other libraries render it as an integer. Okay. So far we haven't seen any difference in JSON PP. So here's one. Well, I probably should mention that the main difference is that JSON PP is very slow, but nevertheless it has its drawbacks as well. So you can see that for a number in the scientific notation, the rendering in JSON is different to all the other libraries. And here's another example, again showing JSON PP. If you use a very large number and you do something to that number, it suddenly changes from float to integer or something like that. Yeah, the first number is different. I'm not sure you can recognize this number. It's probably 2 to the power of 64 minus 1 or something like that, or 32. I'm not sure. I'm too nervous to do the calculation now. Okay. Another weird behavior is connected to type variables. So let's look at this code. It creates, it declares a package, myIncrementer, and it ties a scalar variable. And you can see that the constructor, the tie scalar, is pretty standard. It just uses the value as the value of the variable, but each time you fetch that variable, it's incremented. So when you look at the code at the bottom that uses the package, it initializes x with the value xa, and we then encode it to JSON 4 times. So think for a second what the output should be. Ta-da. So JSON XS calls fetch twice, which is again something unexpected, I'd say. Okay. So, and the last slide is kind of different than the previous examples because the first 2 lines are for the same version of Perl, but different version of JSON XS. So it shows a change in the behavior of the library that doesn't depend on the changes in the Perl version. And again, if you have a number and you decode it and then encode it, now decode and encode means JSON decode and encode, not UTF-8. The representation is different in the different versions of the library, which again shows a large problem. We don't really change the variable at all. We only decode it to JSON and encode it from JSON, and that's it. And suddenly it's quoted, or it is not. So, the usual answer we got from people was, don't use the system Perl. That's the problem. That's the reason of your problems. Well, generally, I agree that don't use the system Perl is good advice. On the other hand, it wouldn't have solved our problems. It's true that we would probably have discovered the problem earlier, or maybe in several steps, but still, when upgrading our Perl or the library, we would have had the same problems. So, so the original idea was to use just a quick hotfix so we can upgrade everything and not block the upgrade, was to use something like that. So you can see that we have integer, string, and float that are of a wrong type, and to encode them to the correct types, we just call int on integers, concatenate them to an empty string for strings, and add them to 0 for floats. This fixes the problem, but we usually use quite complex nested structures in our API. So tracking all the values back to where they come from is a bit harder than it seems. And it's problematic because once you have the structure and you just look at one of the values somewhere, it can change. So you have to be absolutely sure that nothing happens after you've prepared the structure to be encoded. But that's quite confusing for people from non-Perl teams that sometimes need to change our code as well because of changes in some non-related parts of the system. So we decided that it's not a way to go. Moreover, doing this was kind of redundant because we already have a formal API description. That's what our customers use to write their code against. So we have a grammar that says what kind of members you can have in the structures and what types they should have. So the idea in the end was to somehow reuse that formal definition to ensure the types. So we created cPanel JSON access type, which defines several constants for atomic types, JSON type int, JSON type float, JSON type string, JSON type bool, and JSON type null was added later. For complex structures, you can use the normal, usual brackets if you want to name all the members one by one, or you can use this JSON type array of JSON type hashoff if you just want to say all the values have the same type, regardless of their position or key. And there is a special function for alternatives that is JSON type any of, and you can give it a list of types, and it could have any of the listed types. There are some variations. So for all the atomic types, you can add or null at the end, which means null is possible for that value. It's not converted to empty string 0 or whatever. And the same for alternatives. So you can say JSON type null or any of, and a list of possible values. There are some limitations. For example, in JSON type any of, you can have only one scalar, one array, and one hash, not more than one of each type, because otherwise it would be quite hard to find which one applies to the given value. It can be like nested somewhere in the depth. There can be the thing that differentiates them, and we wanted it to be fast. This is not something that should make any impact on using the APIs, so we didn't want to have backtracking there or something. Okay, so the solution was to pass the formal API definitions into some kind of structures, and these structures then can be passed to cPanel JSON access with this type. So you can see that here the type variable is populated with a structure that describes the type for the given symbol in the API, and then we just encode the data using the type, which will like change the type of each member of the structure according to the type. The problem was that in order to be able to do it, we had to like insert the code directly into cPanel JSON access code. It's not possible to make it standalone, because you need to hack into the internals. So it was a bit problematic at the beginning. There is an example, so you can have a better idea of how it works. You can see that the type is a complex structure. It defines 1, 2, 3, 4, 5 keys, and the values are of different types. One of them is an array of integers, the last line. And you can see that then you can encode a structure. So we just like added a new parameter to the encode function, optional parameter that specifies the type, and then the output is as one would expect. So quotes are added or removed as needed, and the boolean is rendered as true, not 1 or whatever. Okay, there was one problem with that, and that was recursive structures. So if there is a structure that can be nested in itself, if you use just the naive way of saying that, so I'm modeling a tree, I have a node which has a value, and also it has a list of children, and it's just a type array of nodes. So again, we have nodes as children of a node, but this creates a reference cycle. So we have a memory leak and problem with global destruction and so on and so on. So we didn't want to have this problem. So we added a JSON type weaken function that you can use for recursive parts of the structures, and it does what it should. It weakens the reference somewhere inside, so you don't get any cycles. JSON type weaken has already been merged in GitHub, but the version containing it has not yet been released to cPan. There is the output of the code on the previous slide. So we see a tree that has a root and child 1 and grandchild 1. Okay. Another feature is type decoder. So it's something that kind of works the other way around. When you decode a JSON structure to Perl, you can also specify an optional argument to the decode function, and it must be a variable that can be changed, and it will be changed into a structure that describes the structure of the of the really. Oh, I'm sorry. So I have to finish very quickly. So you can see that this interface is some kind of not pretty yet, because we have just numbers that you have to look into the source, the C source for their meaning. But you can use the constants to compare to these numbers. There are some links to some other people solving or having similar problems. It's not about JSON every time. DBI has similar problems because SQL is typed. I'll probably skip this one. Okay, so thanks to Pali. It's my colleague and it's the main author of the code of this module. Thanks to Rainy Urban, who accepted all the pull requests and made it possible to hack into his code. And thanks to Good Data for supporting open source. Thank you. Any questions? No. Okay, so you can find the slides at this address, and that's it. Thank you again.